longest subsequence with limited sum. You are given an integer array names of length n and an integer array queries of length n. Return an array answer of length m, so that's going to be the same length with query array, where answer of I index is the maximum size of a subsequence that you can take from names, such that the sum of its elements is less than or equal to queries of I. A subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. Okay, when we look at this XML, we have this one as an input array. Okay, let me sort that one so we can add one by one, right? For example, we want to get 3. How many elements we have to add? 2 elements, right? 2 2 elements we can add, because if we add 3, it's gonna be over 3, right? So it must be less than or equal to queries of I. Now the queries of 0 is 3, that's why we cannot exceed 3, right? The sum. So now we have 2 elements. Okay, what about the next queries element? We want to get 10, less than or equal 10 is okay, so we will plus okay, 4. So how many elements? 3 elements, right? So even if we want to add like 2, 4, 5, it's gonna be 3, right? Oh no, no, it's gonna like this, 1, 4, 5, it's gonna be 10, so it is still 3. But why I don't think about that one? Because we already sorted the input array, so by doing that way we will add one by one, so we don't have to care about the remaining parts. Okay, so now we have 4, right? If we add another 5, it is over 10, so we will not take that one, we will stop here. How many elements? 3 elements here. Okay, what about 21? So we trying to add 1 plus 2 plus, okay, is still less than 21. What about this one? 7 is still less than 21. What about another one again? Okay, now it is 12. 12 is still less than 21. What about another elements? No, we don't have another elements more. Okay, so how many elements we can add? 4 elements, right, in that subsequence. So how many elements? 2, 3, 4 is the result we want. Okay, so we will solve this problem by I will sort the input names array first, then I will try to add one by one. Okay, let's solve the problem by this approach. First, I will sort that one. Sort, right? Names. Okay, let me create another variable, and then m is gonna be length. Okay, and then let me create the answer array. It's gonna be the input integer array, right? So new integer, how many elements in that? M elements, because it says of length m, right? M is the queries array's length, right? So it's gonna be integer array m length. Okay, and then I will loop every queries every elements in queries, right? So I less than m, and then I plus plus. Okay, let me create the count variable. It will start from 0, and then sum will start from 0, right? And then I will loop every name in names, right? And then I will add again name. Okay, if sum is still less than equal queries dot I index, at the time I will plus plus, right, to my count value, else I will break it. I don't have to go again, right? And then after this, for each, right, after this one I got how many elements I added. That's why I will add answer of the I index with count value. Okay, and then after this one is done, we will return answer. Okay, let's submit to see what will happen. Okay, so here is already, the solution is already given. So the first one is we will sort and count, right? So this is the one I solved by this way. Okay, so here how we will think about the complexity, right? So we sort this one, so this one is gonna take n log n, right? And then we looped again, this one is m, right? This one is m, this one is n. So this one is gonna take m into n, right? So if we sum it up, so this one is gonna be order of m into n plus, this one is something like this, right? M plus n log n. This one is from sorting. Okay, this approach is from this one. Okay, so we can do a better solution. Let's try to solve with another way again. Okay, so now here is my input array, right? So I will solve the same way, 5. Okay, and then here we need to add again, right? Okay, for if we want 3, we will need to add steady from 1 again. When we need 10, we need to add 1 again, 2 again, 3. So we need to start from 0 to the elements we want, right? So we need to loop again this part. So instead of doing this loop, I will work with the binary search in this one. Before I use the binary search, I will sum the previous values. Like if now I will add 3, how many elements in front of me and then plus me. Okay, so how many elements? 2 elements, right? So the sum is 3. Okay, I will add 3 plus 4, 7. 7 plus 5 is gonna be 12, right? So and then I will loop every query's elements the same way, right? So 10 and then 21. So at that time, if it is 3, I will call the binary search function. Hey, I want 3. I will pass this array and then I will pass this value, the one I want. Okay, hey, I want 3. Okay, I will search 3. So binary search, it divided, right? It divided half and half. Okay, so now the middle element is 3. Okay, now I got 3. So index is 0, 1, right? Index 0, 1. And then I will plus 1 to the index. So we will got 2. How many elements? 2. Okay, so what about 10? Hey, this array, I want 10. One I am looking for, I cannot, there is no 10, right? So the middle left is just 7 at the time, right? Is 10, 12. At that case, okay, we cannot find that one. So I will take the left index, is gonna be at 7. At the time, 7 is at the index 2 plus 1 is gonna be 3. The same way, if it is 21, it's gonna be this one, left plus 1. Okay, okay, let's try to solve that one the same way. I will sort the input array first, then let me create those variable. Okay, before I create those variable, let me sum the previous value, right? Okay, so to do that, for integer I equal when I less than n, because I don't need to add the first element with the previous element, right? Because there is no previous element in front of index 0. That's why I will start from index 1 and then I plus plus. Okay, and then I will add every previous elements, right? Names I minus 1. So I will get this array, right? Okay, then I will loop queries elements, right? I it's gonna start 0 and then I less than m and then I plus plus. Here it's semicolon, right? Okay, and then we have the answer array, right? Answer I is gonna be, I will call binary search function. Okay, hey binary search, I have this array and then I want this value, give me the index, give me the value. Okay, so and then I will return as a answer. Okay, so I would like to create another helper function. It's gonna be whatever it is, private or public, that's okay. And then binary search, I will accept the integer array names and then integer value. Let me create the target. Okay, so according to our binary search algorithm, we will divide, right? So before I divide, let me create the variable left index, left pointer, and then right pointer. So left is gonna start from 0 and then right is gonna start, let's well be right pointer is gonna be length minus 1. Okay, and then I will check this case until left is still less than right pointer. I will keep going, right? Mid valued right minus left by 2, so we got the mid value, right? Then I will compare, hey, mid value is equal to the target. If they are equal, oh yeah, we got what we want. So for instance 3, right? So there's 4 elements, so left is gonna be 0, right? It's gonna be 0 1 2 3, right? So 3, so 0 plus 0 so 3 minus 0, 3 minus 0 is gonna be like 2.21, right? So left is 0, 0 plus 1 is gonna be 1. So mid index is 1, right? Okay, numbers at the mid index is 3 and then the target is 3. So we got what we want. So we will return the index plus 1. So because now 3 is at the index 1, right? But we need 2. That's why we need to add plus 1. Okay. If nums mid is less than target, then we need to move our left pointer, right? Mid plus 1 is like according to our binary search algorithm. If it is not, we will move right pointer to the left side, right? Mid minus 1. Okay, then I will keep going again. So for this case, if it is 10, okay, so the middle values is 3. Okay, 3 is less than target, right? So we moved left index. So left index is at 7 and the right index is still at 12. Okay, at that time left is still less than or equal. Okay, at that time then we will find the mid values, right? So if we find the mid 0 1 2 3, so we got 0 1 2, this one still the same, right? So middle value is gonna be the same. Okay, so at that case left pointer is 7 and then right pointer is at 12. Okay, we stop from this while loop, we get out of the while loop. At that time I need to return, hey, numbers at the left index is greater than target. I will check that one. Now 7, right? 7 is less than target? No, it is not. At the time, we were at +1. If it is not, we will get left values, okay? Then we will cut the pointer, the value we want, and then we will insert that one. Then we will cut what we want, okay? Let's see if it is working or not, okay? So value and, oh yes, it should be here, yes. Okay, I'm gonna submit this one to see what will happen. So instead of summing again, we use the binary search, right? So what is the difference, the time complexity? Because I referenced the solution, the official solution, that's why. Let me go for the complexity. Okay, so we sort this one, right? So it will take n log n, order of n log n, right? Okay, n log n. So then we need to sum again, right? So it is gonna take order of n. And then what about this one? It's gonna take m, binary search will take log n, right? So this will take m log n, right? So when we sum it up, it's gonna be order of n log n from the solution, from sorting, right? N log n and then m log n from our binary search, right? From this one. And then it's gonna be like n, but that's okay. So if we send like order of m plus n and then log n, this is the complexity we have, okay? So we can reduce from this to this, okay, by using binary search, okay? So okay, so that's it. Thank you.